All right, let's dive right in. Today we're talking about a programming language that you've probably heard of, but maybe haven't really dug into, F#. Is it really the hidden gem that its fans claim it is? Well, let's find out together. So, if you're a developer, I'm guessing this slide hits a little close to home, right? That sinking feeling when you get a null reference exception in the middle of the night, or trying to untangle that spaghetti of callbacks in your async code, or, just writing tons and tons of setup code before you even get to the interesting part. Yeah, these are the frustrations we all deal with.
But what if you didn't have to choose? What if there was a way to have it all? A language that gives you that clean, simple syntax of a scripting language, but also has the rock-solid reliability and speed of a compiled language. Well, that's the big promise of F#.
Okay, so let's get properly introduced. What is this language that promises so much?
Now, this is the official definition, and I know it's a bit of a mouthful. But the key phrases to latch onto here are multi-paradigm and .NET and JavaScript. Multi-paradigm just means you're not locked into one style of coding. You can do functional, object-oriented, whatever fits the problem best. And because it works with .NET and JavaScript, it's super versatile, running on the same platforms as C#, and even being used for front-end web dev.
Now this is where it gets really interesting. Look at how it compares to languages we all know. The goal here is to get that same simplicity and readability you love in Python, but combine it with the compile time safety and raw performance you'd expect from something like C# or Java. That's a pretty compelling mix.
The real secret to F#'s power, though, is its whole design philosophy. It's not just another language that happens to have some functional features, it is functional first. So let's unpack what that actually means for you as a developer.
These principles, they're total game changers. Immutable by default means that once you create a piece of data, it can't be changed. Think about that for a second. That just eliminates a massive class of bugs, especially when you're dealing with multiple threads. And powerful type inference means you get all the safety of a strongly typed language, but the compiler is smart enough to figure out the types for you, so your code stays clean and uncluttered. And this quote just nails the real-world benefit of all that. When the language itself is designed to prevent errors and cut down on busy work, you get to spend your brain power on what really matters, solving the actual business problem you are hired to fix. Okay, that all sounds great in theory, but let's see how this stuff actually helps us write better code to solve real problems.
Okay, take a look at this. This is a feature called a discriminated union. Instead of creating some huge class for a payment method with a bunch of fields that might be null, you just define a type that can only be one of these specific things. A payment is either a credit card, or a bank transfer, or a PayPal. It can never be some weird, invalid mix of them.
And the impact of that one little piece of code is profound. You've made it literally impossible for your program to represent bad data. You can't accidentally stick a bank routing number onto a credit card payment. And even better, when you write code to handle payments, the F# compiler will actually yell at you with an error if you forget to handle the PayPal case. It basically shifts bug finding from your users in production to you, right there in your editor.
All right, here's another one of those wow features. This is called units of measure. Notice how we're attaching units, like meters and seconds, directly to the numbers themselves.
And here's the crucial point. If you tried to write code that added distance and time together, your program wouldn't even build. The compiler itself knows that adding meters to seconds is nonsense, and it stops you right there. This prevents a whole category of bugs in scientific and financial calculations before they can ever happen. It's amazing.
And what about asynchronous programming, the thing that gives so many of us headaches? Well, in F# it looks like this. Inside what's called an async block, the code just reads like normal, simple sequential code.
This is the magic of it. You use that let keyword you see there, and F# handles all the complicated callback chains and state machines behind the scenes. You get to write clean, easy-to-read code that doesn't block, all without the usual mental gymnastics. So, if we were to boil everything we've seen down to its core, what are the fundamental pillars of F#? Well, it really comes down to three key ideas. These are the three words you'll find right on the official F# website. Succinct, because the syntax is clean and type inference gets rid of all that boilerplate. Robust, because features like immutability and those discriminated unions we saw prevent bugs before you even run the code. And performant, because it all compiles down to highly efficient code on the .NET runtime.
Okay, so the language is clearly powerful. It's got some killer features, but is anyone actually using it? Let's take a look at where F# is making a real impact out there in the world.
First off, F# is not some new experimental thing.
It's been around since 2005, coming out of Microsoft Research, and it's been a fully supported language in Visual Studio for well over a decade. It's mature, it's open source, and it has a long history of solid development.
And its use cases are pretty impressive. It's not just a one-trick pony. Of course, you see it in web and cloud development, but it's found a really strong home in these high-stakes areas like quantitative finance and data science, places where correctness and performance are absolutely non-negotiable.
And digging in a little deeper, you see there's a whole ecosystem. There are frameworks like the Safe Stack for building web apps, Fabulous for mobile apps on iOS and Android. It's used in trading algorithms, business intelligence, cloud infrastructure, and even for scripting in video games. It's a true general-purpose tool.
In this quote, this is incredible. To build a complex data system, deploy it to over 90 different markets, and have zero calculation issues, I mean, that speaks volumes about the language's promise of robustness. F# just works. That's some powerful testimony.
So, to bring it all together, F# really is this mature, functional-first language that manages to blend the clean, simple feel of a language like Python with the strong compile-time safety nets of a language like C#. And while a lot of other languages are trying to add these features in, the F# community would tell you that F# is already there.
Which brings us right back to our original question. When you see this unique combination of simplicity, robustness, and performance, all in one package, you really have to wonder, is F# truly programming's best-kept secret? Based on what we've seen, it just might be.